Hello, so today we have International Math Olympiad 1962. Now I would try the problems from the latest years, but I did review them personally, and hell, I'm not solving that in a century, but who knows, maybe I'll try to scale it up with channel running, maybe eventually I will. So I'll start with the fourth problem, not the first one, because I find it less tedious. So we have the sum of squares of cosine of x, cosine of 2x, and cosine of 3x, and it's supposed to equal to 1. Now, immediately, you can note two things. First of all, the squares allow us to double the argument while getting rid of the squares. So cosine squared of x can be rewritten as 1 plus cosine of 2x over 2. Cosine squared of 3x can be written as, okay, wait a second, let me rewrite cosine squared of 3x plus 1 plus cosine of 6x over 2. It's going to be equal to 1. Now, as for cosine of 6x, there is a neat formula for cosine of ray alpha, right? But I don't remember it at all, so I'm going to redrive it real quick. You can skip this part if you do remember it. So what we have is cosine to alpha times cosine alpha minus sine to alpha sine alpha, because 3 alpha is just 2 alpha plus 1 alpha. So next what I'm going to do is I'm going to rewrite cosine to alpha as 2 cosine square root of alpha minus 1 times cosine alpha minus 2 sine square root of alpha times cosine alpha. Now we can bring the 2 sine squared alpha inside of the parentheses, so what we get is 2 cosine square root of alpha minus 2 sine square root of alpha minus 1 times cosine of alpha. Now this can be rewritten as 2 cosine square root of alpha if we add 2 and then subtract it. So what we get is 4 cosine square root of alpha minus 3 times cosine alpha. And what we get in the end is 4 cosine cubed of alpha minus 3 cosine of alpha. Now we can apply this here, and let's do a substitution. Let's say that t is equal to cosine of 2x, and what we get is 1 plus t over 2 plus t squared plus 1 plus 4t cubed minus 3t over 2 equal to 1. Now we can get rid of the ones because we have 2 halves and 1 on the other side. And then when we multiply this thing by 2, what we get is 4t cubed plus 2t squared and minus t. I think. T and a half. Okay, yeah. All lines up. Oh wait, no, it doesn't, because I multiplied by 2. Yeah, okay. So this is what we got in hand, and now we can bring out the t. Then we can just divide this all by 2. And I could have just, I could have just grouped this stuff and then multiply by 2. T squared, 2t squared, plus t minus 1 equals 0. Now here t is equal to 0, and here with the correct formula, t is equal to negative 1 plus minus here when we find the root, it's going to be root of 9 is going to be 3 over 4. So t1 and t2. t1 is going to be 1/2 and t2 is going to be negative 1. So we've got 3 roots for t. Now recall that t is cosine of x, so cosine of x is equal to 0 have and -1, and we need to find solutions for all of this. So what we're gonna do is gonna take the union of solutions for specific cases. Cosine of x is equal to 0. Okay, this is cosine of 2x. I forgot to mention that. Okay. Cosine of 2x is equal to 0 only at pi over 2 plus pn coordinates. So we divide this by 2. So that's tx, 2x. So x is equal to pi over 4 plus pi over 2 times n, where n is an integer. Now remove this part. Next, let's work on the -1. For cosine -1, it happens only once every cycle at the pi coordinates, so pi over 2 plus pi n, where n belongs to the integers. Alright, cool. And now we have the 1/2, which involves two solutions here. Here we have negative, this would normally be pi over 3, but we divide by 2, so negative pi over 6. Here we have positive pi over 6. And then it's going to be added a cycle. And since we divide by 2, it's going to be pn plus pn. And belongs to the integers. So cool, we found the solution. Now as for the first problem, how to find the smallest natural number n, which has the following properties, where essentially the last digit is 6, and if we move it to be the first digit, then the number quadruples. So the way to characterize this with parameters is what I'm going to do is I'm going to say that without the digit 6 anywhere, neither the last nor the first, it's going to be called x. So what we're looking for is 10x plus 6. And the thing about this is that when we multiply by 4, it's going to be the same as x plus 6 times 10 to the power of n, where n is some integer that would represent the length of the digital representation of x. So let's work on this. First we get 39x plus 24 is equal to 6 times 10 to the power of n. Okay, cool. And now with this on hand, we can divide everything by 3 to get is 13x plus 8 is equal to 2 times 10 to the power of n. Now finally what we get is 13x is equal to 2 times 10 to the power of n minus 4. And what we have to do is we have to find an x such that it's going to be divisible by 2. Okay, no. We're going to find the x, and first we need to find n that would satisfy this thing. And we need to minimize n. The lower the n, the lower the x is going to be. So we're trying to find the smallest natural number here, and 10x plus 6 is monotonically increasing, so we need to find the lowest n that would make this equation be solvable in integers, and then we need to verify whether x is an actual proper number. So okay. So what we're gonna do is we're gonna say that 10 power of n minus 4 has to be a multiple of 13. Otherwise, stuff is not gonna match up nicely. And what I'm gonna do is I'm gonna find the map for exponents here. So we have 10, and since we start with 10, we're just gonna be at the remainder when we divide by 13. Nothing changes. Now we're gonna multiply that by 10, get 100, and let's subtract stuff. So it seems that 7 here is the largest amount of 13s that you can subtract. So what we get is 91, we get 9 here. Okay, next 90 minus 13. Oh yeah, what we need to get is a remainder of 4. 90 minus 13 times what? Times 6. So 91 is gonna be, what we need, 12. Okay, cool. 112 minus 13 times what? Times 80, it seems. 80 plus 24, that's gonna result in... Okay, no, that results in 16, I think. 90, that's gonna... 170, okay, that's gonna result in 3. 30. Minus 13 times 2 is gonna be 4. And that's what we're looking for. That's exponential 2, 1, 2, 3, 4, and 5. Alright, cool. So the fourth one was what we were... The fifth one is what we were looking for, so 10 to the power of 5 minus 4 3x is equal to this times 2. Now we need to divide by 13 and we get the x. 10 to the power of 5 minus 4 over 13 times 2. Now again, it's a multiple of 13, but we don't know what kind of multiple it is, so we still need to calculate this. So we have 9996, I think. Wait a second, I'm being stupid. Okay, no, 99996, okay. Divided by 13. Okay, let's do this. So for 99, it's gonna be 7 minus 91. Gonna be 8 here. 89. We're gonna go with 6 here. So 60 plus 78. Gonna result in 11. This will be on this 9. And from what it seems, it's gonna be 8 this time. Or not. Okay, 80 plus 24. Okay, yeah, it seems it's gonna be 8. Okay, cool. 13 times 8 is gonna be 104, resulting in 15. And 156 divided by 13. That's gonna be... Okay, let's... 10... Yeah, okay, it seems to be... It seems like I did a mishap somewhere. Or did I? I definitely have, huh? Oh, yeah, I did. Here's gonna be 9, huh? 90 plus 27 is gonna be 117. You get 26, it's gonna be just 2 here. Okay, cool. Now 7692 times 2. We need to multiply this out, and what we're gonna get is 15,200 plus 184. So 15,384, I think. Alright, so now we just add 6 to the end. Cool. Now, to verify that when we plug 6 in the beginning, it results perfectly in quadruple, let's pull the trusty calculator. So 6, 1, 5, 3, 8, 4 over 1, 5, 3, 8, 4, 6 results in 4. Okay, cool. So that's the solution. That's it for today. Bye.